Welcome to the video on the midpoint formula. In this video I'm going to introduce the midpoint formula and go through 3 or 4 examples on how to find the midpoint between 2 points. And I'll also do one complex example where we're actually given the midpoint and an endpoint of a segment and asked to find the other endpoint. So in front of you here is the actual midpoint formula, and it's nothing more than just taking the average of the 2 x values and the average of the 2 y values. That's all it is. These subscripts, of course, as you saw in our distance formula video, they're basically just indicators for each different point. The 1's go together and the 2's go together. So this would be 1 point and this would be another point. So to find the midpoint between 2 points, you just basically average the x's and average the y's. You add them together, divide by 2, comma, add them together, divide by 2. So let's give it a shot. We'll start simple here and we'll see what we can do. Alright, find the midpoint between these 2 points. We'll call it point M. Our midpoint formula is always going to be this sort of blank shell of a formula. So I like to sort of set that up first and get it ready to go. In the distance formula we use some minuses and some pluses, but in this one we're just going to use pluses. So what we want to do is sort of assign x sub 1, y sub 1, x sub 2, y sub 2. So this whole second point has subscripts 2, and this whole first point has subscripts of 1. So the formula calls for both of the x's to get added, so I'm going to go 1 plus negative 4, negative 3 plus 5. So here we go. Let's see if we can simplify this. Sometimes we're going to get fractions out of this, sometimes we'll get integers, but it's never too difficult. 1 plus negative 4 is negative 3. Negative 3 plus 5 is 2. So our midpoint has coordinates negative 1.5, comma 1. Now I have a graph over here so we can hopefully make some sense of this. I'll plot my red point, negative or 1, negative 3, so that's going to be down here. And I'll plot my green point, negative 4, comma 5, all the way up here. Now the middle between these two, the midpoint, we said is at this location. So I'll put that in maybe an orange or something, maybe a blue actually. And this blue point, this midpoint, is negative 1.5. So I'm going to go left 1.5 and then up 1. And you can see that that makes a lot of sense right there. And the distance between these two and these two is the same. That's what it means to be the middle. And if you wanted to, you can confirm that by using your distance formula. Number 2, this time we're given a graph and we're asked to find the midpoint between these two. Now you can look at this graph and say that it's probably somewhere in here somewhere. So if I had a guess, I would probably guess, you know, somewhere along the same place as the last one, like negative 1.5, comma 1. But that's not really good enough proof, so let's go ahead and actually check this. So let's call that point A and this point B. Point A, we would have the coordinates, let's see, 1, comma 3. And point B has the coordinates negative 4, comma negative 1. And the midpoint between the two is simply going to be the sum of the x's, so 1 plus negative 4 over 2, and the sum of the y's over 2. And we get negative 3 over 2 and 2 over 2. Yeah, sure enough, it is the same midpoint as the last one. I didn't intend for that. Negative 1.5, comma 1 is point M. So this distance is the same as this distance is what that means. Alright, so those are some pretty basic examples. What happens when we're actually given an endpoint and the midpoint and asked to find the other endpoint? And this is pretty important to graph this. So I'll plot this first endpoint in blue. I'll call that, I don't know, point E for endpoint. I'll put my midpoint in red, -5, comma, -2. And I'll put that as point M for midpoint. And I'm looking for the other endpoint of this sort of imaginary line segment. So if you can imagine, if this is our midpoint and this is one of our endpoints, our other endpoint's got to be like down here somewhere. And that's what we're looking to find. Alright, so let's do this. Let's write down our midpoint formula. M is equal to the sum of the x's over 2, the sum of the y's over 2, and the first endpoint is x sub 1, y sub 1. The second endpoint we don't know, so what I'm going to do is I'm just going to put -4 plus the other x and 3 plus the other y. The other y, let's call it point F, or the other endpoint rather, we'll call it point F. We don't know the coordinates of those, so we'll just simply call them x and y. If you don't want to use those subscripts of 2, you don't have to, but I'll leave them there. And that's equal to the midpoint. Well, the midpoint we already know, right? The midpoint is -5, -2. We know that. So what I'm going to do is pull this old trick, right? In order to find this x value, what I'm going to do is get my highlighter out and I'm going to say, okay, this is an x value and this is an x value. So I'm going to simply set those equal to each other and solve it. -5 equals -4 plus x over 2. To solve this is simply just a rational equation. We're going to get rid of that 2 in the bottom. So multiply everything by 2. When you do that over here, you get -10. When you do it over here, these cancel. Add 4 to both sides. Get -6 is equal to x. And we're going to use that same trick for the other side. We're going to say that this is a y, and this whole thing represents a y term. So let's go ahead and set these equal to each other as well and solve that separately. -2 equals 3 plus y over 2. Again, we're going to multiply both sides by 2 to clear that denominator. They cancel. We get -4 equals 3 plus y. We're going to subtract 3 and get -7 is equal to y. So our other endpoint, we're calling it point F. I'll put it in green. Has coordinates of -6, comma, -7. And let's check that on our graph to confirm. -6 would be 6 in this direction, and -7 would be 7 in this direction. And that makes sense. Visually, to me, that makes a ton of sense on my graph. And I always like to make connections, visual connections, to make sure that things are sort of lining up. So that distance is the same as this distance, point F. So there you go. That was 3 examples on the midpoint formula. The last one, of course, being a little bit more challenging, but hopefully made some sense to you, and I'll see you in the next video. Thanks for watching.